Question number 2. Below is some information regarding the probability of several events. The probability of A is 0.31. The probability of B is 0.52. The probability of A union B is 0.67. The probability of C is 0.46. The probability of A intersection C is 0.13. The probability of B intersection C is 0. Calculate the probability of A given B. So the probability of A given B is the probability of B intersection A, well, which is the same as A intersect B. Notice we don't have an A intersection B or a B intersection A for that matter. We're going to have to figure that out. Divided by the probability of B. So we have this new formula. The probability of A union B is the same as the probability of A added to the probability of B, take away the probability of A intersection B. We know the probability of A union B is 0.67. We know the probability of A. We know the probability of B. So we can figure out the probability of A intersection B. I'm going to replace what I know. So the probability of A union B is 0.67. The probability of A is 0.31. The probability of B is 0.52. We can figure out the probability of A intersection B. So I add the 0.31 to the 0.52, and that gives me 0.83. I'm going to subtract 0.83 from both sides, and that gives me negative 0.16 is equal to the negative probability of A intersection B. Divide both sides by negative 1, and you have 0.16 is the probability of A intersection B. I'm going to replace the probability of B intersection A, which is the same as A intersection B. I'm going to have 0.16 divided by the probability of B, which is 0.52, is approximately 0.30769, or 30.769%. And that is 2A. 2B, the probability of B given A. Remember, the probability of A intersection B we figured out in section A is 0.16. The probability of B given A is the probability of A intersection B divided by the probability of A. Well, we know the probability of A intersection B is 0.16, and the probability of A is 0.31. So we just divide them, and that gives us 0.516129 approximately. Okay, it goes on forever. I'm going to convert that to a percent by multiplying by 100. We have 51.6129%, and that's 2B. 2C. The probability of A given C. The probability of A given C is the probability of A intersection C divided by the probability of C. Now A intersection C, we're given right here, 0.13. The probability of C is 0.46, so we just have to divide them. So 0.13 divided by 0.46, which gives us 0.28261. Multiply by 100, that gives us 28.261%. You can leave it as a decimal or write it as a percent. These are identical. 2D. Probability of C given A. The probability of C given A is the probability of A intersection C, or C intersection A, I don't know why I wrote it backwards here, divided by the probability of A. So that is going to be 0.13 divided by the probability of A, which is 0.31. That gives us 0.41935, and to write that as a percent, I'm just going to move the decimal place 2 steps to the right, or multiply by 100. That gives me 41.935%. approximately. And that's 2D. 2E, the probability of C given B. The probability of C given B is the probability of C intersection B, or B intersection C, same thing. Do we have a B intersection C? Oh, yeah, we do, 0. The probability of B intersection C is 0, so this is the same thing. What C has in common with B is what B has in common with C, it's the same. Divided by the probability of B. The probability of B is 0.52. So that's 0 divided by 0.52. 0 divided by anything that's not 0 is 0. Like, how many times does 0.52 fit into 0? Not at all. So the answer is 0. F, the probability of B given C. The probability of B given C is equal to the probability of B intersects C. Once again, this is backwards. This should really be the probability of C intersect B, but it doesn't really matter. B intersection C is 0. So we have 0 divided by a non-zero number, so that is 0. 0 divided by 0.46 is 0. And that's it for question number 2. Have a good day.